Okay, let's look at third question. It says O, A, and B are fixed points such that OA is equals to this, OB is equals to this, where I, J are actually unit vector. What is unit vector? A unit vector is a vector that has a magnitude of 1. A vector has two components. Okay, one is the magnitude, the value that you see, and direction. Okay, and for unit vector, this magnitude is 1. So what are you left with? Actually direction. So vector, unit vector, this is unit vector. Unit vector is a vector that has a magnitude of 1, and these vectors are used to define direction. Now usually, generally, I is a unit vector towards x-axis and J is unit vector towards y-axis. So minus 4i means we have to go 4 units in the negative y direction if we are plotting the vector on the graph. Okay. Now given that this equals to this, p is greater than 0, find the value of p. So let's, if you want, you can just do the whole thing at once, but I'm going to break it down. So magnitude of OA is equals to coefficient of the first unit vector and a square of that plus coefficient of second unit vector and a square of that. So that becomes p squared plus 16. Similarly, for OB, magnitude of OB is equals to square root of coefficient of first unit vector 1, coefficient of second unit vector 2p plus 1 whole square, which becomes 1 plus 4p squared plus 4p plus 1. And if we simplify this, it becomes 4p squared plus 4p plus 2. Okay, now square root of 2, OA is p square root of p squared plus 16 is equals to magnitude of OB, which is 4p squared plus 4p plus 2. Now I'm going to square on both sides to get rid of the square roots. So I'm left with 2 into p squared plus 16 is equals to 4p squared plus 4p plus 2. This becomes 2p squared plus 32 is equals to, if I bring the whole thing to the left side, it becomes minus 4p squared minus 4p minus 2 is equals to 0. So minus 4p squared plus 2p squared, so I'm left with minus 2p squared minus 4p, and then 32 minus 2 is equals to plus 30. I'm going to multiply by minus 1, so I can get rid of this minus. 2p squared plus 4p minus 30 is equals to 0. I can divide the whole thing by 2, so I get p squared plus 2p minus 15 is equals to 0. Now we have to do middle term factorization. So I'm going to take the first term, the n terms, and multiply them. So p squared times minus 15 is equals to minus 15p squared. Okay, I'm going to ignore p squared and minus 15. Okay, and sorry, the minus sign. So 15, how can we represent 15 in with the as a product of two numbers, 1 into 15, 3 into 5, 5 into 3, that's the same thing, so we stop here. Now we are going to write the n terms. We have to break down the middle term into two terms. Okay, now the n terms have different signs, that means middle terms will have different signs as well. The first one will have positive, since the positive here. The second one will have the negative sign. Both of them will have p, and there's going to be two numbers here. Okay, and we have to find the difference of two numbers from here. We have to find a combination where the difference is basically 2. 15 minus 1 is 14, so not this one. 5 minus 3 is 2. That 2 matches with these two. So that means this is our combination. Okay, if you ever get stuck, you can follow this method to find middle term factorization. And obviously in this case you can just plug this equation into your calculator and just solve the equation. So for our case we will write the larger number here and the smaller number here. So we can now factorize p plus 5 minus 3 into p plus 5 is equals to 0. So if we take p plus 5 common, from this side we are left with p, from this side we are left with minus 3 is equals to 0. So that means p plus 5 is equals to 0, p minus 3 is equals to 0, p is equals to minus 5, p is equals to 3. The question said p is greater than 0. So that means this is not acceptable. Therefore, p is equals to 3. This is our answer. Now, the second part says, using the value of p, find the unit vector that is parallel to AB. You might, the question might say sometimes say towards AB. Okay, so both are the same thing. We have to find the unit vector. So as I said before, unit vector is a vector which has a magnitude of 1. Now, if we have to find the unit vector towards AB or parallel to AB, what we have to do is we have to in AB we have magnitude and direction. So we have to isolate this direction. How are we going to do that? We are going to divide the whole thing with the magnitude. Okay, the whole vector with the magnitude. So magnitude cancels out, we are left with the direction. Okay, so the whole vector, so unit vector is equals to the given vector divided by its magnitude. So you see we have the whole vector and then we are dividing it by magnitude. Now we don't have the vector AB, so we have to find vector AB. AB is equals to final point, which is B, and its positional vector. Positional vector is basically defining from origin. Okay, OB minus OA, or you can think of it like this. You have O here, you have A here, you have B here. So if you need AB, you have to go to O, which is minus OA, and then go to B, which is OB. This is a different way to do it as well. So, but usually I just do final point, position vector of final point minus position vector of initial point. So OB is I plus 2P plus I. Let me write it down. I plus 2P plus 1 into J minus Pi minus 4J. Now value of P is 3. So 6 plus 1 is equals to 7. 7J minus 3I minus 4J is equals to I minus 3I is equals to minus 2I plus 3J. Now that we have AB, we need the magnitude of AB. So magnitude of AB is equals to the square root of the coefficient of first unit vector, square of that, the coefficient of second unit vector, square of that. So we are left with 4 plus 9, that is square root of 13. So we are just going to divide AB, the vector AB divided by its magnitude. So unit vector is equals to, you can write down unit vectors toward AB, blah blah blah. So unit vector is equals to AB is equals to minus 2I plus 3J divided by square root of 13. You can leave it like this, but common practice is we always write coefficient and then vector, okay, not vector plus vector divided by number. So minus 2 by square root of 13, we are breaking it down, I plus 3 over square root of 13 j. This is how we always write vector. You can see the same thing getting reflected here. You have the entire coefficient and then the vector, the unit vector basically. So this is our unit vector. You can actually check if it matches with the definition. So this is a unit vector, that means the magnitude of this vector should be 1. So let's check it out. A square root of, this is not part of the answer, your answer is right here, your answer finishes right here, we are just checking. Okay, minus 2 over square root of 13 squared plus 3 over square root of 13 squared. Let's put it in the calculator and see if we get the same results. This should be 1 basically. Minus 2 over square root of 13 and square of that plus 3 divided by square root of 13, that becomes 1. So it matches. So if you want to validate your answer in the exam hall, you can just do this and see if it comes up as 1. If it doesn't, that means you made a calculation mistake. So that's all.